Welcome back to the stream. For anyone who happens to be tuning in live, like right at the beginning, I guess it's Sunday afternoon here. I don't have a huge amount of time to stream, but I wanted to at least update on the cat following robot project, because it's, it's fun, and it's making a little bit of progress. That is the cat in question, always in need of additional robots to follow him, as you do. Garrett in chat points out that it's gimbal time. Ken was giving me a hard time about it being a gimbal instead of a gimbal last time. But yep, it is totally gimbal time. Let's see if we can get all the relevant cameras going here. Hello, folks. Let's have all the hair on one side. So, as you can see, we've got the camera in the gimbal / gimbal. And so, I've got this mapped up to an Xbox controller, same as last time. XY axes, or the x-axis maps to, what is that? Yaw? I guess I'm always forgetting the terminology here. So that maps to yaw, and the way the software is written right now, this control stick and this stick are just mapping pretty much directly to like servo motor style RC aircraft kind of outputs. And what just happened? Okay, so I was going to explain that actually, but and then this screw, I just noticed this screw, and I'm wondering if that just flew out of something. Jeez. Are there 2 screws in that bracket still? There are still 2 screws in that bracket. Okay, that was exciting. Anyway, yeah, so as you can see, it's mostly working. I have been occasionally seeing this vibration where, so it's similar to what the gimbal does when there's just no camera mounted. I did very gently try that. It's of course in the manual. It's like, don't power this on without the camera mounted is the first warning. So of course I'm like, well, if I'm going to be hacking on this, I actually need to know how bad that failure mode is. So what I did was to kind of hold all the axes so that they wouldn't vibrate uncontrollably, but I would be able to tell what the motor driver was trying to do and kind of resist it a little bit with my hands. And with that, I could tell that it was going to start oscillating pretty violently, just having it powered on for a couple of seconds. So with this, I've gotten it into a couple of states where I think depending on the angle, it will sometimes start vibrating. So that started me down trying to debug that. So that's why there's this thing taped onto the side that's a counterweight that I'm using right now. It's not actually necessary though. Let me show you what it works like without any of those modifications. So I did this this last modification off camera because I was feeling lazy about the videography. But basically, the last stream ended with this combination of modifications to the gimbal hardware and printing this bracket right here and drilling some holes in this camera housing, also that I can mount this, also that I can mount this camera, which has an SDI HD video output, in this gimbal that's designed for a GoPro, so that I can get real-time HD video out of this thing for my cat following robot, both for streaming purposes and for computer vision purposes. So let's see. So I also had this on here as a counterweight piece. But yeah, so basically the problem we had last time was it had a tiny range of motion, but then you turn it that far and then it would hit this back bracket. So I was going to 3D print a new bracket. I mean, basically that started me down the, noticing that the, this is having some trouble with focus today. So I never really modeled the whole gimbal in CAD. I just modeled the minimal pieces because I was kind of doing it as quickly as I could. And so it would be nice to actually have a model in CAD of how much space I have for this whole contraption. And that could be as simple as, measuring pretty well relative to everything I already have. Where is this actual axis located? Which, it's going to be between those two screws on the bracket, but just measure how far back it is, make an axis there, then measure kind of conservatively how much space do I have around that free, then put that in the same CAD diagram, and then figure out how much forward I have to offset it. But I didn't really like the idea of that messing up my center of gravity that much, and I felt like I was probably going to end up having to move it more than I really wanted. So then I noticed the places where it was actually hitting weren't structurally necessary. So then I just took this thing over to my belt sander, which is a little tiny belt sander, but this is soft aluminum, so I had to dunk it in water pretty frequently to keep it from burning my hands, but this wasn't too hard to do. And so this is actually not too bad as far as this axis is concerned. It's balanced pretty well and it's free to move. So let me show you what that looks like. Gently power this on. I mean, powering on is pretty gentle usually. Okay, so you might have heard a tiny bit of rattle. I think it might have done that with the GoPro, but I don't remember for sure. Oh, neat. Wildmania in chat says that they're about to start a stream in less than 15 minutes, and so there might be some overlap too, but maybe if you have the bandwidth, you could watch both. Let's see. So this is actually not bad. So let me see what mode this is in. I think it always powers up in a mode where this axis, what is that called again? Yaw. The yaw axis is locked and pitch axis is active, but you can hold down that third axis acting as a mode switch. There's like a certain amount of time you have to hold it down, which I haven't quite trained myself to do. Okay, so now I switched it into the mode where it's locked. The controls are locked, but this is still stabilizing it, which is fun. Then next mode. So I didn't, okay, now it switched. Oh, did I not switch it? See, I haven't quite figured out how long to hold that down for, but now I'm in the right mode. And so this is actually pretty good. But, so the vibration problem, which I don't know if the counterweighting will fix, that was bothering me, but that's not actually why I think I want to print another version of this bracket. So the problem I noticed was when you power it off, it just kind of like slams over. And then so I was thinking, oh, that's not good. And of course, it can also easily get itself into a position where it's not really going to be able to unstick itself on power up like that, which would be annoying if this thing is in the air. I'd have to have a procedure to lower it down so that I can manually unstick it. But anyway, the reason for that is that this, this pitch axis is pretty good, but the roll axis is really off center right now. And that's because the GoPro, like the bracket that I designed is doing its best to keep the optical centers lined up. So like all it can do is be only as thick as the aluminum bracket. So by being only that thick, I'm doing my best to keep the optical centers lined. But then that has the side effect that I wasn't considering of making that axis really unbalanced. So the GoPro was actually sticking out pretty far to counteract the weight over here. And that made its optical center way over here, but it doesn't really matter that much. So I could counterweight it over here, which is what I was doing with the washers taped on the side, and that seemed to help. But I also don't want to make this heavier than I have to, so I think the ideal solution is just to make a new version of this bracket, which is thicker and lets the camera sit further back. So I think the first step is to maybe just fuss with this model and try to see how much space I need to make this roughly balance, and then to make the design changes in CAD, and then print another one. And that's probably where this stream's going to have to end, because I don't really necessarily think we have the time or interest to sit around waiting for the print, because it's probably going to be like a 45-minute to an hour print, and I probably only have like maybe 3 hours tops to stream today. So some more CAD mostly, but I thought you might be interested to see the progress on having this actually work, because I'm certainly excited to see the gimbal still operational after that extreme disassembly, and it's nice to have this coax and the 12-volt output all working, so that seems pretty awesome. And yeah, I like the way this moves. It definitely feels nice, and I would still like to try to fuss with the firmware on here so that instead of having these, so the inputs on here, it's the firmware on here is like cooking those in various ways to like convert them. It's assuming that you want to be steering the camera, so it tries to keep the pitch axis kind of automatically centered at around 30 degrees unless you're telling it to look up or down. So it almost works like panning in video game camera physics. So like you can like tell it to look up. So like if I had to mock this up, you could like tell it to look up, or you can tell it to look down, but then it kind of centers right there. I don't know why I'm doing this for pretend. Like I could just power this up again. It does a pretty good job at like soft starting when you power it on. So, and then I think it always powers on in the mode where at least one of the axes are locked. So I think it's like a threshold of like 2 or 3 seconds. I mean, there also might be something weird about like the ranges of the actual analog values that I have to send. I don't know. There we go. I thought I just saw... That's weird. I thought I just saw it move in that axis, but... It'd be really easier if there was any feedback whatsoever about the actual mode that it's in. Okay, anyway, that's the mode I was looking for. So in this mode, which is currently the best option until I figure out how to actually reflash the firmware with something that has absolute angle inputs, then what I've got is, so this is the neutral position. One thing you might notice is that the Xbox controller in particular has a pretty wide amount of slop in what mechanically it'll center on. So it's pretty easy to get this joystick outside of what the microcontroller considers to be the dead zone of the centering. So if you see it kind of wander a little bit, that's probably because the joystick is a little off-center. But if I don't have the joystick off-center, it stays put, then I can tilt it up. Oh, let me try to actually hold the joystick into the center position carefully. I mean, I could easily fix this in software, but so far I haven't, because right now I want the software to be just like a straight pass-through for, easily debugging purposes. So, I can tilt that up. I'm still pushing the stick up, but then I let go of the stick, and it kind of softly settles down to something. It seems to have like a spring return such that if it's not pointing somewhere between like the horizon and 30 degrees down from the horizon, it returns to that range. Which just seems to make sense for like a helicopter. And honestly, that might not be a terrible mode of operation for my cat camera, but I'd like the ability to have some more software in the loop in terms of pointing the camera. So ideally, and this doesn't have to be the first step, but eventually I'd like this to have some notion of where it is in 3D space in the room, and where the cat is in 3D space, and some like vectors in between those objects. But for the moment, minimum viable flying cat cam could just be flown by this Xbox controller, and it would still be easier than chasing him around with a tripod. So yeah, and then you might see that, well, okay, so I can also point it down. Oh. If I point it down too far, the motor goes into oscillation, so I might want to limit that. Although some of these problems might be less bad once I have the the camera circuit board in there, because right now the camera's a good bit lighter than it. I mean, the lens is the heaviest part of the camera, but the circuit board has some heavy heat sinks on it. But yeah, that motor oscillation is not something I want to let happen when this is actually operating. So yeah, and then I can point up. Yeah, so the yaw axis here is hard to keep centered because you can basically just push in either direction and it moves in that axis until it hits the stops. I don't think the firmware has an accurate idea of where the mechanical end stops on the motors are, because once it hits the end stops, it's not violent about it, but then the motors just start drawing some extra current like you would see from a regular servo motor. It can turn around, not quite 360 degrees. This would be nice if I had like an on-screen display of the control values. Which, oh, I could actually do that. I can hack that together really quickly. Let's go to the Mac, because I feel like the Mac has a better terminal. Got some good old-fashioned glitchiness. Oh yeah, this was the video I recorded before of the camera, or of this gimbal with the GoPro. I was using this as a reference to see how it moved before the modifications and disassembly. This was with the same software too. But yeah, you can see so the camera, I don't know, I haven't actually weighed them to compare, I probably should have. But this one definitely sticks out farther on the side. I think this is actually maybe... Yeah, I don't know actually which one's heavier, because this has a plastic housing, but it also has a battery, so... I think the camera that I put in is probably a little bit heavier than the GoPro. But, yeah, mostly it's battery weight versus aluminum weight. Anyway, let's SSH into this Raspberry. That is the wrong keyboard. It's the kind of thing you want to know before typing passwords if you're into that kind of thing. But I think right now I just need to SSH into this thing that I've already got credentials on. That's right, I already named this Tuco Cam after my cat. Let's kill that cam steer is the Python process doing the work. And let's make things a little more convenient and actually give us a nicer way to edit code on this Raspberry Pi. Stop bouncing, little iTunes. Go away. I don't even like you. Do I have a mount directory? No. Can I do that? Yay. So here's a text editor that is remotely accessing my home directory on the Raspberry Pi. So I just have this little Python file. I don't think I've checked this in anywhere. This is just like hacked up based on... It's mostly based on... So this is super convenient on the Raspberry Pi, in fact, because I'm using this breakout from Adafruit for the PCA 9685, which is it's designed as a pulse width modulation chip for like LED drive, but it's also works well enough as a servo, pulse driver. It's not super high resolution for that, but it works well enough. And Adafruit has a really convenient library for it that you can use with the Raspberry Pi with really little configuration. And since it's an I2C board, you can just plug it in pretty easily. So I'm using that. The Raspberry Pi also happens to ship with a driver for the Xbox 360 gamepad, which was convenient because I was already planning on using one of those for, kind of a local manual wireless control for this. And so that uses a Microsoft-specific wireless protocol, but then there's a little receiver dongle that plugs in over USB. And there's a Linux driver shipped with the Raspbian image by default that gives you... so if you go to proc input... No, proc devices. I used to know this. I've actually got code in the kernel in the input subsystem, but it's been a while since I've done this. Maybe this moved to sysfs. Sys devices input. Anyway, there's a Linux input subsystem. I'm going to want to do this as root. Anyway, I have a better... Oh, proc bus input. Yeah, that's what I was looking for. Yeah, so this is like the most straightforward way to just ask Linux about its input devices. It has a pretty nice input subsystem that represents... I don't know, like if you've used the USB human interface device spec, it's similar to that. It's got its own like Linuxy flavor, and they're not directly compatible, but they're pretty easy to glue together, and they have a similar feel to them. So here you can see all the devices, and this Xbox thing I don't think this is actually a standard HID USB device. Microsoft purposefully made it non-standard, but there's a Linux driver anyway, and then it exposes it over the HID, or over the Linux EVDev event device interface, which then gives you something that's also pretty abstract, kind of like HID. So it tells you it's got buttons and axes, and so that's actually pretty nice. And there are actually several Python wrappers for it. I'm using one that's just this Python evdev module. And so that, I think that was pretty straightforward. Let me get this to fit on the screen more. So I'm reading the joystick on a separate thread. I think that was because, like right now I'm just gluing these like one-to-one, but what I wanted to do was to do some processing at a fixed rate on the main thread that was independent of the rate that events come in from the input device. And the easiest way to do that in Python was to use a thread. So I have a separate thread here, which I've got this separate function here that's just trying to find a sensible Xbox by looking for a joystick with an absolute x-axis. And then I guess I'm storing some information about the axes extents so that I can scale whatever arbitrary units the kernel device happens to be using into like floating point, which is a little easier to deal with. And then this is the thread's main loop that actually runs just continuously. And it sits here waiting for events. This is actually kind of clever. It's using a Python. I mean, I'm not trying to say my code is clever. I'm saying that the interface that this library provides is kind of clever in the way that it uses a Pythonism. They just have a Python generator, basically, so that you can iterate over the result of this read loop call. And the read loop is this function that sits there actually doing whatever operating system specific, I mean, in this case, Linux thing. Actually, I think the reason the abstraction boundary here is useful is because you can have different read loops that, that wait for events in ways that are compatible with different frameworks. So this is a really basic one that just sits there waiting in a read system call, getting one event at a time. But if you want to interact with like a GUI event loop, or there are some other event frameworks in Python that I'm forgetting the name of, but they have different versions of this loop. So basically this is the encapsulation for the functionality involved with, getting an event and obtaining control flow in the Python interpreter when that event happens. And then in this case, we don't need it to do something fancy because we just have a thread acting as a really big hammer for that nail. And then in this case, I'm just storing the status of that event and assuming that on a separate timer, basically on the main loop, we're going to be periodically looking at the current state of the joystick and then doing something based on that. But we don't necessarily need to do processing when an axis changes state. This has a placeholder for something to do when buttons are pressed, but right now it's just printing out. So I think all I want to do here is, is there a way to do set servo? So, yeah, this is a little bit, so then the API for the pulse width modulation thing, the Adafruit library doesn't know anything about servos. They just had some example code that shows you how to calculate a pulse width that corresponds to a particular servo. Because like the controller that you're talking to is a pulse width modulation controller, so it wants a duty cycle. And so you've got to do a little bit of conversion to convert the pulse width you want in microseconds to the duty cycle. And it's not super high resolution, but it works well enough for us. And anyway, this was just my little bit of Python code for that. And actually, I think mostly the reason I don't have this printing out to the screen already is that I have each servo channel going through a separate code path here. Stop bouncing, iTunes. Jeez, I'm going to decline you. And instead, I want to do this as an array kind of thing. So, yeah, I can also try to clean this up slightly. I'm still going to calculate or leave this microsecond calculation somewhat repetitive because I expect to have to fuss with that. Since this is like very temporary code, I shouldn't, and like especially for very, very temporary debug code, you don't want to be making too many layers that you're just going to have to burn down the next time you change anything. But I definitely want all the axes to be treated through this kind of list-based code path instead of making a bunch of separate function calls. So then I'm going to print that so I can see what's going on. Oops. This is the VMs tainting my keyboard muscle memory. I'm pressing Control V instead of Command V. What operating system am I even using? I guess also the problem is I've been using Sublime Text on all the OSs lately, so and the UI looks so similar that it's like I start to forget which operating system I'm using. 'Cause it's like, oh, I'm sitting here, but I can sit here and be using any of the OSs. Oh man. Human brains are so not designed for this. Maybe I don't need to deliberately change those variables there to be less descriptive. I can make these match the original ones. This is the floor division operator in Python will not convert it to integer if it's already been floating point. So I guess I should actually be rounding that. Not like it really matters, but cool. Let's do that. You working? Buttons are working. That's interesting. Is this something I'm misunderstanding about Python? Oh, did I not save it because of the keyboard shortcut problem? I think that might be what happened. I think I pressed Command S to save it. Ha ha ha. That's better. Okay. So that should be roughly microseconds. Now for the thing where we put that on. No. No, I think I actually just want it to be on the same screen, but turn where the overlay is on. That'll do. It is kind of tempting to make that bigger at the risk of totally screwing up my presets. Okay, that was worth it. Oh, geez, this is bothering me having so many digits of precision, because, geez, this is this is not that accurate. Here, let's take a different approach. Let's have that be an integer still, but then up here, let's just do let's do this the functional way. Oh, you know, there's probably a function to do that already in math, but I'm used to math round still giving you a floating point. Let's just try this. So that's not a thing. And floor should still give you a float. Yeah, that's not what I want either. I mean, I could just I can make this even more functional. Hopefully that made somebody happy. I should just make this round if I'm going to do that. Or is there no math.round? I don't care. I'm using floor. Given how accurate these joysticks are, it really, really, really doesn't matter. Oof! Where did that come from? Okay, well, two things went wrong. That's still giving me... Oh, damn it! Control S Command S strikes again. And this vibration snuck up on me. How did that even happen? Can't tell why that happened, other than maybe just the camera weight being wrong. Anyway. Right. Math. Math is a thing you have to specifically ask for. Oh, I already have it imported at least. Command S. Okay. That's finally what I wanted, I think. Gently power this thing up. Oh, sorry, I've been neglecting chat. Andrew is asking whether I updated my bracket or just modified my camera housing. And yeah, this is the same bracket I printed on the last stream. I'm actually going to modify the bracket, I think, for a center of gravity issue, but I solved the interference by just grinding away part of the camera housing. Oh, geez, what is up with the color on that recorder? There's so many things to go wrong in this setup. I don't really need the recorder until I do CAD, but I'll have to go over there and look at why it's messing up. Anyway, so maybe that's a little more instructive with the numbers there too. Yeah, this joystick has like no dead zone, and the trying to be careful about how far up and down I push it just because of the motors, but anyway, I could have my own software limitations on the angle if that's necessary, assuming I can get the firmware to allow me to specify more of an absolute angle instead of these just like joystick inputs that I've got right now. But that's a separate problem to solve. I think I'm done fussing with this, and we should just do some CAD. Oh, that's a better shot of the actual bracket. This gimbal is actually very smooth. It looks jerky in the way I'm moving it right now, but that's really just because this joystick is so twitchy. When I was trying this out with the camera just taped in place, I found it actually pretty easy to steer, even with this kind of janky joystick setup, when I was looking at the video output instead of trying to do this just based on looking at the gimbal. But yeah, it's definitely, like, I should maybe just change the range of scaling on this joystick, because the middle is really where I want most of the time. And it moves pretty smoothly. And then, of course, the smoothness is a lot more evident if you actually pick this up. And so, you know, this isn't going to be moving around a ton, but basically, you know, imagine 4 long cords connected, and this will be kind of wobbling around. And this kind of movement isn't going to matter that much as long as the camera is relatively far away from the stuff that it's photographing, which is probably going to be the case. I'm going to be using the lens in zoom mode most of the time. But, you know, imagine this kind of bouncing around as the motors winch it along and the image staying pretty stable. I think that's going to work out pretty well. And, you know, the winch isn't going to have to keep this super flat, which I don't think it will. So it's being all gimbally. I'm really excited to get video through there, but if I attach the coax to the circuit board right now, I won't be able to get the bracket off and replace it. So one thing I might want to try to do in redesigning the bracket is to make it so that there's a slot to get the wires out without having to pass the wires through the bracket. If it looks like I can do that, then I could route the wires. Well, it's going to be hard to get the wire, like, just to set to, I was going to suggest a way to set this up just for testing with the video actually coming out. But the way it's designed right now, the wires really have to pass through the 3D printed piece. So if we're going to change that out, we need to do that next. For some more context, Nicholas missed the whole winch design meeting, and they're asking if is it XY or XYZ. I think there are actually going to be 4 axes on the winch, but basically the goal is to move it around in XYZ in the shop here. So, the reason for having 4 winches is really more to do with having the volume fit like a rectangular space, rather than having a triangle inscribed within that rectangle that my camera can reach. Since I think in a lot of the cases where I'm using this, it'll want to be kind of backed into one of the corners potentially, in which case you're really just controlling it using, the geometry is such that you're only really using 3 of those winches mostly. So that's also part of why I wanted the force sensors on the winches, as I think that with 4 of them, I think the geometry is going to be kind of weird enough that it'll be nice to have kind of a closed loop feedback system to keep that knows about the forces on all 4 of the cables, so that I don't end up with any of them going slack. Especially, I can keep them all within some boundary of minimum and maximum tensions. So yeah, 4 cable XYZ robot. That's a good concise way of describing this, as Nick puts it. So I am noticing, you can see on the screen behind Tuco that recorder has, I think, misunderstood the color mode of my HDMI signal. Actually, it might fix itself when I switch this back to the other computer. Did that change anything? There's a lot of lag on that recorder. It might also be seeked back into the recording. Let me just take a look at it. Get another technical interruption. Oh, there it is. All right, that problem seems to go away when I switch the channel in the HDMI switch. You may have guessed that it's a warmer day in the shop today. Usually I'm complaining about how cold it is, but it's actually pretty toasty today. Good old California. Which mouse? I really like doing CAD with the trackball, but it's connected to the Mac right now and I don't feel like moving it. Alright, I think I can maybe, is there an undo on this so that I can quickly change this back to the way I had it? I don't think there is, but let me just do that. Oh man, this trackpad, like OBS, its UI is fine. It's maybe not the best, but it's certainly not the worst thing. But using it over, like, this is like the worst capacitive touchpad. This is like if a capacitive touchpad was designed, oh, that was not what I meant to do. Like a capacitive touchpad designed as a first semester EE student project. It's like, yeah, I'm really glad you got this working, but it's not what I want to be using every day. Let's lock that so I don't move it around. All right. Get that out of the way for the moment. Switch. There's the switch. Okay, I think I can unplug this gimbal. I've been worrying slightly about how happy this gimbal is at running, for long periods of time without a lot of air cooling. But, I mean, it gets warm, but it doesn't seem to be getting dangerously hot. And, I mean, it will maybe have a little bit of air cooling as it's moving around. It also wouldn't hurt too much to add like a big slow fan over this whole assembly, because I will have a stack of warm electronics here. I mean, the gimbal, the camera, the SDI amplifier, and the Raspberry Pi are all going to be putting off a good bit of their own warmth. So, I mean, if the fans aren't that heavy, and if it's spinning at a constant rate, then I probably don't have to worry about it being too much of a gyroscope. Actually, having a fan acting as a bit of a stabilizer might not be terrible. Although I'd want it spinning slowly so it isn't loud. Anyway, I hope I don't have to put a fan on this. That would probably be more trouble than it's worth. Oh, so maybe actually before going to CAD, our first design decision is, how much do I want to move this? Which I think involves kind of weighing things and using calipers. Caliper town, population me. Oh man, these calipers. These are actually really fancy calipers. They're like way fancier than I need them to be. They were a gift from someone who didn't really need them and had gotten them from their employer, I think. And they're like solar powered. And I feel like I've been mostly taking good care of them, although you'll notice this chip on this inside measurement jaw, and that was completely my fault, and I feel terrible about it. I dropped it, and it landed on the concrete. But for the most part, these calipers are still in pretty good shape, and I like them a lot. But yeah, I think all my other calipers are the kind of, probably less than $30, and are good enough for just like checking stuff really quickly, but not necessarily something that I would want to rely on for a really, really critical measurement. Or, I think honestly the biggest problem I had with the really cheap calipers is bad power management in the circuitry, and they would just eat through batteries really quickly, whereas this one is solar powered, which is nice. It does make it hard to use at night. I have to put a very white window up on the monitor if it's the only thing lighting the shop when I'm trying to measure something. Alright, so this is a terrible camera angle. I got the camera way too out of the way. Alright, so this axis is pretty well balanced. When I kind of measured it myself, well, before modifying the case, measuring just the non-modified case, the lens, and with the circuit board, so a couple of small differences. The center along this plane was pretty much right at where you see the exposed threading on the lens mount. So that's now lined up pretty well with the center of the motor here. So this axis is actually feeling pretty well balanced. Like you can see right now it's a little front heavy, but it also doesn't have the circuit board installed yet, so it's probably about right. This is the axis I'm concerned about. That one's just no good. I mean, you can see that it works, but it strains the motor more than it needs to, and honestly the thing I'm most concerned about is when it loses power, it'll just slam this pretty hard against the top, which might not be a problem every once in a while, but I don't want that happening on a regular basis. So, oh man, maybe it's time to go servo AF here. I don't really trust my ability to keep my attention focused on that and everything else. Maybe that's also just too close. Feel so... for anybody who hasn't seen one of the previous streams where I've had to go into a digression fussing with this camera arm, it's really convenient, but it also breaks down a lot. And every time I clamp it, it's like, will it make that noise that means the bearings are all jumping out of their sockets this time? Alright, so I think what I want to do is take these screws out and then maybe insert some like spacers there and figure out how many spacers I need to keep this balanced. I think that might actually be pretty easy to do, since I have plenty of M3 screws around here, and I think I even have some spacers that will do the job. So let me get a little bin of M3 screws, and we'll try that out. These are M3 by 25s, which seem like a good starting point. But I really, I don't have a super well-equipped shop in terms of mechanical parts, but M3 screws, I've got those. Maybe not all the lengths I could have, but I've also been known to occasionally, when I need a really small M3 screw, or like a really short M3 screw. You know those, I would go get an example, but I'm feeling like that's an unnecessary digression. There are these crimping tools that are really, really terrible. Basically, they're sold as like a 3-in-1 tool where it has like a crimper, a wire stripper, and a bolt cutter, and it's like this like squeezy thing. And I have one. They're really, really bad as wire strippers or crimpers, but they're actually not terrible as bolt cutters for small bolts like M3s. Of course, granted, I think the one I have is not metric, but so it doesn't give you like a clean edge because it's not going to be quite the right size, but it does kind of work. These gimbals are really satisfying to work on. I mean, that's one thing I've liked about, I mean, I'm not super into model helicopters, but I have been somewhat into them in the past. And one thing I really like is all the meticulous little mechanical stuff that you have to repair inevitably. So that's the bracket we've got. It's a cute little thing. And the right wrench. Man, I really chowdered up some of the M2, really tiny M2 hardware, specifically like the panhead bolts on the original gimbal, because I started out trying to disassemble it using this, this thing. It's like a really shitty, like, I don't know, you get these things that have like a bunch of different screwdriver heads, but I found that, like, at least when I shop for the really cheap ones, none of them are the right size. Like, none of them are the size they claim they are. And so I ended up with something that was like a little bit too small and messed up the screw heads. But I think even when you shop for really cheap, economical, I don't know, I just don't like... I like to be able to have a lot of variety of stuff in my shop, so I don't necessarily like to spend a lot of money on a particular thing unless I know that I need it to be a really good instance of that. So that's part of why I take pride in shopping for entry-level equipment, so that I can have that stuff around when I need it. But yeah, the cheap, just plain old hex keys definitely seem to be better machined than the like magnetic screwdriver sets. Trying to catch them in stream, and I don't know if there's enough context quite, but I might scroll back in a sec. Welcome to everyone joining. I've been enjoying this gimbal hacking. This gimbal, I've been really happy with its construction. You know, it seems to have a really nice design. It's based on, you know, a pretty respectable microcontroller for a motor control thing. You know, it seems there are a lot of little features I've enjoyed, like the mechanical parts all fit together really nicely. The wire routing is actually all pretty well done. It doesn't use slip rings or anything expensive like that, but given the level of parts they're working with, they're actually doing a really good job of, you know, keeping things precise and well put together. Alright, let's try... This might be a little easier to work on without the top of the gimbal anchored. I feel worried about putting too much stress on it doing this. But as long as I hold this piece as I'm putting the screws in, it should be fine. Alright, peace of mind here. I'm going to disconnect this. Oh, let's be careful with that wiring harness. That connector is a little tight. And this is my new micro coax, terminated in a comparatively enormous SMA connector. I could have terminated it in something smaller, but the video amplifier I'm putting it into has an even bigger connector, which again I could change, but the simplest solution seemed to be to terminate the micro coax very carefully in a regular size SMA plug, and then to just use a common SMA to BNC adapter. Okay, so now I'm cradling the gimbal carefully so I don't put too much stress on the joints as I tighten these screws. These holes could have been bigger for more clearance, but I mean, it's kind of nice having these snug. I don't know. I can see an advantage to having them not like wander in these holes, because they have a pretty wide clearance in the camera, so there's not like an over-constraint problem there. Oh, this is tempting to do with a power tool. Oh, I don't know if I have a good... Well, again, with the problem with the badly made like driver tips, the hex keys like this are great, but it's been really tempting to take a hex key that I don't need and find get a grinding wheel in the Dremel and just cut it up and make power tool bits with it. Somebody in chat, Milan, says that they just got back from watching my playlist and stopped at the Mandela effect. I don't even know what you're talking about. I don't remember. Like, I just do electronic videos. I mean, I also do cat videos, but... Okay, these aren't going to seat all the way down, but that's fine. You know, it's also possible that I don't need to 3D print a bracket, that I could just use spacers to attach this, if it's rigid enough, but I suspect the bracket, like a new version of the bracket, would end up being better. One of the weirdest things about being on the internet is just how, everyone else ends up having this little mental model of you now that's, of course, quite divergent from the real you, but it exists, and every once in a while you have to confront it. Oops. Yeah, I've been wanting to get an electric screwdriver. I don't actually have one. I have a power drill, which has it has like a clutch, but it's not really something that I feel super comfortable with using on gentle parts. super much. Anyway, I think that's in as much as it needs to be. Maybe I don't need to 3D print anything new. This might actually just be strong enough. And, I mean, it would leave open some room for adjustability later, for sure. So, some standoffs. What do I have? I've got these. How do I have more of those? Let me find those. Maybe I'm in a different place where the wide ones were going to hang out. Unless I already put those somewhere so that they would be handy. Oh, these two don't look matched, but they're the same height. I could start with these, but I think I need more. Ooh, that's threaded in an incompatible way. Anyway, I think I have a bin with a bunch of these. Let me see if I can find that. Washers. Oh yeah, that's right. I think I had it with the washers, not the standoffs, which is why I had some of them out already. Oh yeah, I've got a bunch of these. Why do I have these? These are useful. Little brass standoffs. Let's try a stack of 2 of those and see how far that gets me. I don't know if that might be too much, but... Made myself a little Lego kit. And put some M3 nuts back on there. Oh, this might actually be great. This, I mean, I don't know, we'll see how it balances, but at least this is feeling fairly sturdy and not nearly as temporary as I was expecting it to be. And I mean, this might be stronger than a 3D printed bracket if this is actually the amount of distance I end up needing. That fits like here. That is a little too much. Oh, maybe not. Oh man, is that balanced? That seems definitely close to balanced. I mean, I can't... So it does limit how much roll you get, but that's fine. I don't need much roll. So there's... Oh, this is hard to move because my wires are not taped down like they were before. So if I tape down the wires... this is kind of nice. I think maybe I'll make do with this. assure you, if there are any conspiracy theorists out there that think that I have like crazy, weird political beliefs that I keep to myself, I assure you I don't. I keep my political beliefs pretty out there in the open for people who care. And I'm sure for people who don't, but, yeah. This stream's about gimbals, if you know what I mean. That is upside down. How did I mount that upside down? Oh man, this is such a confusing object. Yeah, I mounted this such that I can't actually swing this around the correct orientation. Let's fix that. So I've also still not quite been sure what I want to do with the coax on here, as far as how to connect it to the board. I think my first thing to do is going to be to try to disassemble the wiring harness that had been attached there and reuse its connector. And if that doesn't seem viable, then I might just use the connector as a solder cup, even though that seems kind of barbaric. I could also desolder the connector, but then it seems harder to attach the shield on the coax. I'll have to check that out. Mike's Electric Stuff is in chat. Hi, Mike. And he says he bought a WoW stick driver, and he says, I bought a WoW stick driver. It's a total piece of wank. It's a piece of total wank, like if Apple made screwdrivers, but not as good. Oh, man. Yeah. It definitely seems to be... Actually, I did buy a little electric screwdriver because it was like cheap on Amazon and seemed like the reviews were surprisingly good. And I got it, and it worked well for a little while, and then the gearbox totally just destroyed itself. But it was like, I think it was $20, maybe $15, something in that neighborhood. There's still tape in the way. Stop being there, tape. I just put that on because I wanted to test this more, but I think I just want to... Okay, that's... Oh, sorry, that's mostly out of frame, but... Okay, that's how it has to be. So, just like that. And with that mounted. And my bolts. I would be worried about putting the circuit board in ahead of time, but I think there's plenty of room for it to clear these nuts. Famous last words, but... if I need a solution to that, then maybe I use slightly less long screws. I'm going to reposition this camera. This angle's not doing me any favors. This camera really captures the intrinsic messiness of the desk, that really this little tiny piece is where I'm using it. I mean, I did clean off my desk right before getting into this project, and now this is just all stuff related to this project. I'm really bad at setting aside time to tidy stuff up. I just always want to be making progress on projects. Okay, let's tape this down again. Okay. Let's gimbal it all up. Oh man, that actually stays pretty balanced even just on its own accord. That's a really good sign, you know? Clamp this down again. Okay, is this ready for power? I think I just need to put the wiring harness back in. And not be shorting these together. Let's have some anti-shorting tape. It looks a lot like regular tape, but you know that it's anti-shorting tape because you see it attaching the red wire to the table. Okay, let's get some of this stuff out of the way. Okay, let's do this. Do you see that there was a bit of a wobble on that axis? Almost like it wasn't as heavy as it was expecting it to be. But now it seems pretty stable. If I perturb it a little bit, it settles. Can we get the motor current on here? Because the power supply is kind of interesting to keep an eye on too. You can kind of see that. Well, so yeah, that's a 1/4 amp at 12 volts. And so you can see that adjust to any changes in workload. So there are some limits as far as how much I can tilt this platform without interference on the bracket. That's a problem I could solve by making the bracket stick out less, for sure. That is definitely a bracket problem. But I think this might be good enough. I think I'm kind of happy with this, actually. Let's try steering it around. Oh yeah, I have to make sure the controller is on also. This UI is confusing. Does it want a short tap, a really long tap, a kind of long tap, a series of kind of long taps? Alright, so now it's in the mode I want. Jeez. I'm gonna assume that that's something that is due to it being too light. So the solution, well, if it persists once I put the camera electronics in, that maybe it's something I have to tune in software. But I think the next thing I want to do is put the camera electronics in. Shh. Okay, yeah, the vibration is unnerving. But let's see how it responds as I move this around. Let's not have it drifting. Yeah, I think that's probably a weight issue. Alright, I think I'm just going to hook this up because I want to get video out of this. I think we're all impatient to see this thing work. So, alright, and if I turn off the gimbal now, So the original reason I made this modification is I didn't want to see the camera just like slam against the axis when I unplugged power. So now we should actually see it just kind of float relatively gently. Oh, that's beautiful. Didn't even move. Okay. Yeah, I'm going to assume that the vibration is probably due to the motors being under too little workload at the moment. So let's see if we can fix that by putting a circuit board in here. And if not, then maybe it's a software fix later on. Okay, so let's make a little room, warm up the soldering iron, get out the microscope. Is Tuco is so passed out, man. Can I get a better angle on him? Oh man, that little tiger. Mike in chat says, I've always liked mechanical stuff, but reliability issues scare me for using it in permanent work stuff. Yeah, that's very understandable. I feel pretty similarly. That's partly why hobby robotics is pretty nice. I mean, this stuff like this actually is probably a good, like, getting your feet wet, though, into making more reliable mechanical stuff, because, like, I want this thing to be running in my shop a lot. Like, you know, I might find a way to have streams that just follow Tuco around, or I might find a way to use this even when I'm not streaming, so I want to make something pretty reliable, and so, you know, it might be an exercise in learning how to fix all the things that break when inevitably the reliability isn't as good as it could be. I don't like pulling this by all the wires like that, but the attempts I've made to push it out with a spudger so far have been damaging the plastic. So that feels pretty nice. Okay, backside. Let's find some maybe better work holding for this whole situation. Put this away temporarily. Let's unplug this old contraption so I can move it aside. Um, 12-volt wires. 12-volt wires are always ready to just fry anything on your desk and ruin your day. Not that lower voltage wires are safe, but it's more exciting with the higher voltages. Oh. Let's see then. Little vise, little vise. Oh, that's kind of nice. That's an angle I can work on it at, and it, like, the rest of this gimbal is resting pretty gently. That's a little close to the end stop there. Yeah, it's close to the end stop, but I don't think anything's stressed. Okay. Oh, camera, arm. Don't be doing that. There we go. All right. Now we're going to start doing some assembly. Although maybe the next step is actually disassembling the wiring harness to see how reusable that connector is. Okay, so generally what I'm doing here, these two are coming in. I might even put a little bit of black heat shrink over both of these wires just to, you know, for looks and to keep them together as they go into the bracket. That would also maybe make it easier to secure these down to the edge so they don't have any way of rubbing. I don't know, I could have made something in the, oh, this is even not a good angle. So, I could have had the wire guide in the bracket work differently to have the wires be cleaner, like, one thing to maybe do if I do end up 3D printing a new bracket. Oh, where is the focus here? That didn't feel good, actually. It didn't click, but that's probably fine. Okay, so yeah, so you can kind of get the idea. And so these are the wires that we end up needing to solder to the camera circuit board. And so the bracket probably could have had a hole, you know, angle, allowing the wires to go this way. I was a little worried about how easy it would be to thread the wires through there, but I think there's a good bit of extra room there. So I think I'm not going to worry about redesigning the bracket super yet, and I'm just going to have heat shrink going over there, and then on the camera side, I can imagine various ways of anchoring this down if that's necessary. I mean, the original camera wiring harness used a zip tie. I might do something similar. But there's also this hole here that was originally for like a side bracket, and I might be able to use that somehow to retain the wires. Like, use that with a little tiny zip tie, or use a little wire that wraps around that screw and holds them in. So, okay. Now, as far as putting the, so I've already got the lens in about the location where we want. I had a clue to help out. There was a little mark left on the lens barrel thread by its set screw. So that helped me, you know, it was a pretty good reminder of where the lens was originally attached, even though I don't think, you know, I think it would have been easy to adjust. It's just, there's just a little grub screw that sets this whole assembly in, and then you can thread it in and out. The other thing to remember is, so even though this assembly looks symmetric, Kenneth, who's the one who brought these cameras to my attention in the first place, has pointed out that they don't really perform well if you don't put them in the right orientation. So I have a pretty good recollection of what orientation this was supposed to be in, but just remember make sure I'm looking at this in the right orientation too. So this is the top of the camera. The housing has a little piece of text that says WDR across the bottom, which should read, you know, as you'd expect it to. And then I kind of have this mental image of, you know, the back panel going on like this, and then under the back panel, the plug that carries mostly the signals for this joystick, but also power and composite video was along here, and then the coax was over there. So I think that's how we're going to put this back together. Let's put this aside briefly and see what we can do with that coax and if we can reuse it, because that would be nice. Because it would be nice to not have to desolder things from the board to take it out. It doesn't really help us much with getting things through the bracket because we still need to terminate everything after putting it through the bracket because the wires are so tiny. We could have a connector for power as well. I don't have a lot of really good tiny connectors for something like that, but the main reason to use the coax connector is just because it makes it much easier to terminate the coax properly enough for this. And so also I wanted to keep this wiring harness around. This little nubbly joysticky thing seems like it would be really useful to still be able to plug in to adjust the menus. This piece of metal is not handy, but I could leave it on if I have to. I'm curious whether I can get these things back through the hole if I cut this zip tie, which I'm probably going to do. And then this is the connector I want to pilfer, because I don't really need it in this harness, and I might have use for it if I can actually get my coax into it. And then this is what I want to keep intact. So let's see if I can force this back through the hole, because it would be nice not to have this piece of metal hanging around. So does the coax fit through? I don't think the coax is going to fit through. I think the coax was definitely terminated on here, but let's just cut the coax off so that we have a clean edge. And then this connector, I think I might be able to kind of put it back through on its side without damaging it. So I'm going to try to bend these wires at an angle there carefully, because that's where it is weakest. And put it through like this. I think this is working. Got one of the wires through. Two of the wires. And the yellow one's at an inconvenient angle. I'm pretty sure they didn't do it this way at the factory. But it does work. Sweet. And it looks like our connector survived. So now I have a way to plug in a remote control if I want to. And I might as well, since this doesn't have any use, I might as well cut this also, just because I'm kind of curious. Yeah, that is exactly the same coax going straight through. Cool, with a very thin jacket over it. Neat. Now I've got one of these ends that might be handy for something else. Okay, so now it is now my joystick and redundant power adapter. Let's get this under the microscope to see how much of this we can salvage. Alfie in chat points out that that flat flex coax exists. Oh yeah, and then Mike was pointing out, yeah, re-getting cables through small holes. I like flat flex cables since the end is no bigger than the cable. Yeah, I like that too. And then wondering whether you can get away with SDI over a short length of flat flex cable, maybe with a balun. That was on my mind for sure. Especially when, before I took apart the gimbal, I was assuming that it was probably using flat flex for the signal, and that maybe it was just, you know, so I even tried running a noise source through the video wire to see what the spectrum response looked like. And some of the high frequency stuff was getting through fine, but there was like a really weird dip around 350 megahertz, and I was like, well, maybe they're just doing something weird, like some kind of intentional filtering that makes sense for composite video, but I would want to get rid of. So it just made me really curious what the signal path even looked like. And then I find out they're just not using flat flex at all, it's just wires. But I did research some about what this, or what you would do to make a flat coax. And so I think the really fancy approach is like a multi-layered thing. But then you can get pretty good you can make a pretty good, I think it's called a coplanar waveguide, where it would be like a flat flex with a thin center conductor and then 2 grounds along either side. Maybe some additional ground stitching back and forth between them. I don't know how necessary that was. But yeah. All right, let's get these cameras back set up to do the other thing. Alright, so we looked at this connector already briefly before, just to kind of marvel at how it was shaped, because I didn't know what it was called, and I'd never seen one of these before. Oh, that's interesting. I hadn't noticed this was hollow on the back before. Maybe that's related to how this cable is assembled. This is the glue that they were using to hold the connectors down onto the camera circuit board, presumably so that when you have your closed-circuit TV camera in the back of a truck, it doesn't vibrate itself apart. But this might be useful for disassembly. Do I have a good digging tool? Maybe a little screwdriver or a piece of, like a terrible tweezer. Is this my terrible tweezer? Ooh, yeah, this one's really bad. Just kind of digging this in around the edges to break the seal, like the actual adhesion between the glue and the metal, and then I think I can try to pull it out in a chunk. You could also do this with a knife, but I don't want to cut anything I care about, which, to be honest, probably isn't anything that the knife would be able to cut. Like, I don't care about the wire yet, because I'm trying to take the wire out. I also briefly looked at how easy it was to just get some of these connectors in low quantity quickly, but it wasn't something I was willing to pay for when it seemed like I could just take this one apart. Okay, knife. Actual knife time. Maybe also actual vise. This thing is so little, though. Maybe if I hold it from this side. Oh, Tuco is so dark on the table there. Oh yeah, so Ben confirms that the hole is how you solder the center wire, so that makes a lot of sense. Yeah, so I might damage the wire, but I don't want to damage the terminal that the wire solders to. Which is probably pretty sturdy. I don't think I'm at risk of damaging it with the tip of an X-Acto, but let's also not cut my fingers. Gunk. Oh yeah. Oh, that's beautiful. Oh man. Ooh, there we go. Oh, that's nice. It's a good little connector. This should be quite reusable. I mean, we may or may not have to destroy bits of the shield to solder the rest of it, but let's see what the carnage is like on this side under the. I assume this is crimped, and I assume there's something we're going to have to kind of unceremoniously pry apart to uncrimp it. where's this bit that's sticking out? Oh, that's, I think, a bit of glue residue. Oh, and then Pepper in chat suggested differential signal, and I mean, I don't think that actually helps. So, like, converting the SDI to differential is an expensive proposition, and probably heavy also. Using something that starts out differential might work, like HDMI, but then I think however you slice it, if you're doing HDMI, you just end up with a lot more wires, and I don't think that would fit in the gimbal. So I think SDI is actually pretty good for what we're doing. Like, a lot of why I wanted to do the camera this way was because it was SDI. Well, this seems to, this isn't much better than my, you know, terrible crimp from the other day. It doesn't have to be that good, though. Alright, let's hold this such that I'm not going to burn myself taking it apart. I don't want to melt my vice jaws either. Oh, Mike says that they'd give it a go without balance first. Is it simple and easy to try? I did do just like the world's roughest without balance experiment. I just like took a length of 30 gauge silicone wire, which I figured would be easy to pass through the mechanical constraints involved, and twisted it with a drill, and then just like rigged it up to some coax pigtails without balance, and it was terrible. I mean, there were a lot of reasons it was terrible, so I'm sure I could have dropped a few of those and made it a better test. But, yeah, I mean, that left me feeling like I probably wasn't going to get too far with an approach based on something, oh, that's still really hot, based on something other than an actual controlled impedance coax line. And this single micro coax I'm using is about the same thickness as just one of the DC wires in the original gimbal design. And so I think it does pretty well. This connector is eminently reusable. That's great. It wasn't even crimped. It was easy to desolder. I think things are going well. I think now let's just leave a reasonable length on the other end, and then crimp it. Yeah, I don't think this is how... I mean, I don't know. I don't know whether these are designed to have a crimp shell over them, but yeah, this doesn't look quite like how it was designed to work. Alright. Where to next? Oh, I still have coffee. Oh, and then I also saw... This might be worth like a quick teardown at some point. I got some cheap SDI balance because I was trying, I was trying various solutions for inexpensively getting video over long cables, and this was before I think I'd found either that SDI in general was kind of a viable thing to do this with, or before Kenneth had found these cameras. And so I saw other solutions. I actually still have. I got some, and these are like both heavy and expensive, such that I probably wouldn't want to use them on CatCam, but I got a pair of HDMI over Cat5 devices, which are very active. They're not just balance. But I think I'm going to, after I get off my lazy butt and actually run the wire for it, I want to run one of those from here into the machine closet so I can get better video from the machines as I'm using them. So, like, I want to use that for that, but it's not a passive thing. So then separately, as I was shopping for that, I found, another one of those times where I'm on eBay and I see like, I'm shopping for this reasonable thing where it's like, oh, this is like $100 and something for a device with a bunch of chips in it that's converting protocols, fine. And then I see this thing that's like SDI video ballon, and it's like 2 for $10 or something. And so I get a couple of those just because I'm like, let's see what this is capable of. But they're rated for only the very slow modes of SDI. Like, it's not good for HD video at all. But I'm still curious, like, putting those through their paces and see, like, what are their frequency response? What is the frequency response actually like? What is the construction like? Because I'm curious now. But I haven't actually done that teardown yet, so I can go in the pile of things for future videos. All right, I think we want to go back to this whole situation. I want to know how long to make this wire so that I can trim it properly. But I want to make sure that I leave myself with some extra length, because I might have to re-terminate this a couple times if I redesign this bracket. And there's no reason to paint myself into a corner with an extra tiny wire here. So that said, I also don't want it to be annoyingly long. Oh, and let's put that heat shrink on before I forget, because that would be annoying. Let's clone the heat shrink repository again. Where are you at, Gimbal Town? Gimbal Town. Population, camera, Tuco, and one crazy engineer lady. I mean, the cat's sleeping through all the good parts. He doesn't know what he's missing. So I actually want this to be somewhat long, because it would also be kind of nice to send this down into that channel for strain relief. So then maybe like that much. A little less. I'm also definitely going to use the multimeter to make sure I know which one of these wires is power and which one's 12 volts. Because that would be an embarrassing mistake. Actually, I think the camera has reverse protection too, but I don't remember for sure. Ooh, that's nice. I like that. Can I retain this before because the heat shrink will retain the shape to some extent when it cools. So if I actually give this a little retaining clip, I mean, I could 3D print a tiny little bracket for this, but I could also just put an M2 bolt in there and run a loop of wire around it, which I think is what I'm going to do at first. There are a bunch of opportunities to make this nicer later, but it also doesn't have to. What even kind of wrench does this take? Oh man, these M2 hardware bits are really satisfying. Can I get the wrench in from that angle? The problem with this is the angle, but just finger tighten this and then use the wrench at the sideways angle when I have to. Oh yeah, I'm doing badly on keeping up at chat, but there was a question on whether these cameras that Kenneth found are IR filtered. And they're definitely not. They're actually, I think, designed to be especially sensitive to IR. I don't know for sure, but I think they might be one of those sensors that has, like in their Bayer mask, like red, green, blue, and IR channels, because it seems to go into a separate IR boosting mode when the light is low. But I don't know that for sure. That's just based on how it seems to be behaving. I need a little, oh, I need a little tiny piece of wire, but that's already over here, because I keep those close by. So, excuse me. It's a little bit like lock wire on a screw. And I guess that's basically what I'm doing. And this, I mean, this isn't permanent either. This will be easy to redo if I need to. I just want to do it before doing the heat shrink so that it retains that shape. And the heat shrink is also something I can redo if I need to, but I'd like to not. I'd like to not have to. Probably somebody who's like done lock wire in a factory forever could do this in like 1/10 of a second. That gives me no trouble. If I had a ball driver this small, that would be really handy. Then I could hold this at an angle while driving it in. At this point, the wire is plenty enough to hold the little harness I've built, but if I put the screw in more, then it'll actually secure these little loose ends, and I can cut them to length. And Tuco's getting a really nice nap in. He is so a cat. I mean, except for in all the ways he's like a dog. Should take him out to the park and play fetch more. I mean, last time I took him to the park, he was not interested in... Well, I mean, I don't know, we didn't really get to the point of like playing fetch because he was just like way too into just taking in his environment. And that's just getting close. This is definitely one case where having... Oh, I don't want to put that much tension on it. Now it's starting to pull the wires. It's not going to set itself as tight as I would like it without it pulling the top wire, is it? Well, I'm just going to put these... I just want these edges not to be shorting anything out for the moment. Okay. I might want to do something slightly better with that later, but right now I'm just going to heat shrink that. Oh. I have to be really careful with the heat shrink and the PLA right there. How am I going to deal with that? Maybe a metal shield. That is too big. What do I have? I had a smaller ruler right here. Here it is. A little bit of heat right there. Okay. I think that's all I want to do to it. So the heat shrink in the plastic is not fully set, but it's fine. It's still acting as a strain relief. Okay. Great. That'll hold it. I really want to try to tighten this without totally crushing the cable, though. Get a better camera angle. I think this is what I want to do. This is feeling like it's actually tightening now. Yeah, okay. I think that's what I wanted. So now that is nicely locked in there, but not tight. It's just kind of held snugly. Okay, great. So now let's cut this to a length. So I think I want that to have about that much length in there. So let's be generous and I'll only trim off about that much. And keep this extra bit with my wires. Normally I would not save a piece of wire that's that short, but you know, micro coax is expensive as far as wire goes. Okay. So now I would like to maybe take this off the vise so that it's a little easier to work with. No more coffee. Okay. Oh man, I'm running a little low on time for this stream, but I'd like to at least get video out of this thing before I've got to go. That's what we've got so far. I'm liking this so far. So now the wires are way less in the way than they were. A little loop holding them in. Okay. So now I just want this to be resting peacefully somewhere nearby while I terminate this coax under the microscope. Alright, that's the connector. I'm so happy that we have a connector. I was not looking forward to soldering this directly to the circuit board for many reasons. Which of these knives is less dull? Oh, this one's actually pretty good. This is the one that I actually have lots of replacement blades for, which is why it's less dull. These two things are related. Alright, so right now... Okay, first of all, how long do I need to strip this? I assume I'm going to do a bunch of heat shrink strain relief on this too. Probably want to strip it back to about that much. That was a little deeper than it should have been. Oh, so I looked into those thermal strippers that Kenneth was mentioning last time in chat. They seem super useful. I couldn't find one cheap enough for me to justify it given how infrequently I would need it, but basically it's I mean, it looks a little bit like your standard kind of low voltage, high current heating tool. So I imagine you could probably build something similar based on like a soldering gun or a rewound microwave oven transformer or something like that. But basically, the thing that it was heating up with its low current or low voltage, high current power supply was a little die that you just, it has just a little slot that you slide a piece of coax or tiny wire into, and with very little damage to the wire itself, it just burns a little hole all the way around the wire insulation, so you can really easily get at coax. That seemed nice. Ooh. Because yeah, they're definitely designed to avoid nicking the shield like I just did, which is not the greatest thing. I don't think it's going to be a big deal here, but it's something that I should learn not to do. This is a little annoying because I can't rotate the other end super freely because it's still going through the gimbal right here. I feel like I keep just going back to the same location because this doesn't want to rotate smoothly. That's what I wanted. Yay, a little coax. This might be a good time to start thinking about a heat shrink. Because for best strain relief, it would be really nice if I had something that would fit, well, thinking about how I attach these. So I think the strategy that worked well last time was to kind of bunch up the shield inside there and then solder basically a bead around that edge. And then, you know, have so the center connection will go all the way through, and right now you can see it kind of bumping into that bead of solder, which is where I'll attach it. So, and it's interesting that these don't have like a metal plug over that, just glue. Because most of the other coax cables I see, there's some metal thing that covers the area where you solder the center connector. Anyway, so as far as heat shrink goes, I think I'm not going to want anything like in between there, but something that kind of makes up the difference in diameter between those two, and then something over the whole thing. Oh, Alfie in chat is sick, and they're oh yeah, spraying ethanol-based NSAID medication directly into your tonsils sounds pretty bad. And the human body is capable of doing so many painful things with the help of its environment and/or itself. How do these compare? Might be might be a little thick for the inner one, but and this one might be a little thin for the outer one. This is 1/16 inch. probably a good outer cover. So it's got a couple of pieces like that. Oh man, now I feel like I'm racing against the clock. I want to put this together and see some video. But I also don't like racing. Like I really like, I mean, you may have noticed I like kind of a calm pace in my work, which is certainly a luxury. But, you know, if you can get it, it's nice. I have plenty of people pay me to make things in a hurry, so it's nice to have something I can make and take my time, you know. After all, it is like, you know, Sunday afternoon, and I'm doing a project that is a fun way to interact with my cat. So I'm not going to beat myself up too much if I don't get video out of it today, but man, it would be nice. Also, it's not like, I might not necessarily have a really hard stop, it's just, actually, if you might have seen him on the stream once before, my friend Zach, who showed up here once before, is just coming over, and so I'd like to be able to hang out with him as much as possible, but it would also, you know, he might just like stop by and hang out while we get the gimbal working, if that's something that's interesting to everybody. Alright, that's not a very uniform stripping job, but once I tin it, I'm sure the extra insulation will make itself scarce. Yeah, look at that. Well, that seems pretty straightforward. I really want a better way of clamping this connector, but the way I did this when I soldered the larger SMAs was just to plug this into something mating, and then have the mating board in a vise, but I don't have anything that attaches to this, other than the camera, which I don't really want to abuse in this particular way. Well, I might just do this with a stick vise and try not to melt it. There's something I can use as a heat insulator. Oh, maybe I'll use this metal ruler as a heat sink. Mostly need this for soldering the middle connector. Soldering the outer shield, I'm going to get this a lot hotter. Let's see if I can at least get the middle conductor in like this. I might need to switch to a different soldering iron tip. Actually, it's really easy just to switch irons between the micro soldering and the regular one. I could also put a smaller tip in the bigger iron, but this micro soldering pencil is really nice. It's nice to use it when something is actually small. That seems good. I mean, not amazing, but you know, it should be good enough. And oh, Nick in chat mentions that there's supposed to be metal plug on here. It just doesn't have that for here. Okay. I want to do the next part. So the heat shrink is on here and hopefully at a safe distance. And do my best with that. And just prop this up on some pliers so I don't melt anything. I need the bigger soldering iron now. Already. One annoyance is, besides changing the plug for the soldering iron itself, I have to change the plug for the stand, since the two irons are, of course, different sizes, and so you can't use the same stand. And then the stand is relevant because there's a switch that tells the soldering iron when to wake up and go to sleep, which is handy, and it'd be nice not to lose that functionality. So I've thought about making some kind of combiner where, I mean, it might even just be as simple as using like an audio cable Y adapter, because it's like 1/8" audio style plugs. And if that puts them in parallel, then that might be what I want, but I haven't checked to make sure I know how it wires yet. Oh, nice. Mike has a good suggestion in chat, who says you could do a tidy job of the shield by winding tinned copper wire tightly around and then flooding with solder. That's a great idea. Let me see if I can implement that. I have a spool of... Oh man, I should probably change these because I always find that I think I just want this on my other... Here I am optimizing my tools. I just want the untinned, really thin wire to be on the same spool as the solder. Not because I need more things to confuse me, but because I do use them at the same time. And the Kynar wire can hang out there too. And these can go back over here. Alright, let me just cut the length of this. Let's try to get this started. Oh man, doing this with so little work holding is annoying. I think I need to find... Well, actually, since I'm not soldering it while I'm doing this, I can use the stick vise to clamp this while I wrap it. Let's do that. Try to untangle what I've got so far. It's really annoying to do with the cable attached to the gimbal like this. I'm just trying to unattach this from what I've already got. I mean, ideally I would hold it from here and then be able to wrap around that way. It's a little annoying, but maybe that's how it has to be done. As much clamping pressure as I can on this vise. me try to just actually tie this wire onto the base of this somewhat firmly. That fails mostly. Might want these closer together. I mean, this part where it actually changes diameters is going to be where I really want the reinforcement. Let's try not to make this too complicated. Let's trim this a little bit. There's too much wire here. Oh yeah, I was thinking about tacking it down with a piece of solder like Alfie suggests in chat, but the main thing is that then that would probably melt my stick vise unless I changed my work holding, so that was the main annoyance I was trying to avoid there. I think this is getting close to something that might work if I just added a bunch of solder now. It's not super pretty, but I think it might be electrically all right. Oh, I really want a way to hold that doesn't melt everything. Can I just leave it to hang free? Okay, let's do the thing. See if it works. Oh, nice. Kyle in chat has been considering making a nice handle switch for the FX951 that would let you switch between handles. Yeah, that would be nice. I would like something. I was thinking about that too, but hadn't considered actually making it that nice. But I would totally build something like that. That's not bad. Let's see what the other side looks like. That's pretty hot still. Yeah. A little hard to see, but It's not pretty, but I think with some heat shrink over it, that'll do nicely. Oh yeah, and Nicholas says the female sockets for the soldering pencils are easily available, but they'd worry about the thermocouple losses. Yeah, that's a good point. I wonder how bad that would be. I'm no expert in making good connectors for thermocouples, but it's definitely something that requires care. Let's not trim this little end out a little bit. All right, that's enough fussing. Let's put the heat shrink on. Alright, so first, this is just going to get as close as it can to that to provide some extra strain relief and kind of impedance matching. And then this one should cover everything else. Be approximately as ugly as the original joint. Tempting, but probably unnecessary to put something over that. Microscope is becoming less useful for that. Oh, Tuco and I were both like, what was that? The neighbors were moving something, I think. Yay. That's much more professional than I was expecting this to be. Well, since that's the case, I wonder if I can find a connector to use for the 12-volt power. Well, let's take a look at the circuit board and see where that needs to go. And see what kind of anchoring points we're dealing with. That coax is alright. A little lumpy, but shielded. Center connector seems to still be alright. Ground myself a little bit. Make sure I have my phone handy. Oh. Oh man. I should wrap this up soon. Alright, well, is there any way I can just put this together quickly for testing? I could supply 12-volt power externally and then use our SDI. Let's just try that and then wrap this up. So, let's do it this way. Oh, there it is. And as for hardware, these are also M2, but I need pretty short screws. And I don't think I have screws that are short enough right now, so I'm just going to put the standoffs that I have in on the sides where they fit, which is the two sides that aren't near my new bracket that takes up some of the space. Yeah, these standoffs now look kind of crazy long. I'm definitely going to replace these with just plain old M2 screws. So then this will plug in on the circuit board right under there. Come on. Is that not plugging in, or is it just... I seem to remember this connector taking kind of a lot of force. There we go. Nice little snap. The coax still seems slightly on the long side. Okay, so those wires are just kind of hanging there. I'm going to try to put this together for another test. Need this thing. Okay, so we got that. Let's connect our temporary thing for power. Great. That can plug in. I actually conveniently have a 12-volt power barrel jack over here. It is also connected to the same power supply. Is it... This might be diameter challenged. That plug is just not very well made. And this needs to plug into everything. Power for the Raspberry Pi, network for the Raspberry Pi. And what else? Alligator clips to power the gimbal. Sure, all of this is thrilling right now. I don't know, I'm excited to see video go through this micro coax we added. So ground for the gimbal, 12 volts for the gimbal. Okay. Oh, that's not good. I also need to fix that up. So run the program on the Raspberry, and then plug in the power. And then I'll need to still get video out of this separately. Come on, channel 1. This one. Oh, Tuco's chirping at birds. All right. Power this up. Oh, I don't have the gimbal plugged in. The camera's powering up. Let's plug in the gimbal wiring harness. was a little annoyed at the wire pulling for a sec, but now it's stable. Cool. And we aim this. There it is, aiming up and down. Let's get the video plugged into the computer and the lens cap off. Video. Let's try this without the amplifier first. I mean, I might use the amplifier even if it doesn't seem to be absolutely required, just because I don't want to be dealing with marginal SDI signals, but like it does seem to be really good at taking something that is not great and then outputting a strong, cleanly clocked signal. All right, so mouse. Let's get the video on the screen. Oh, I need need an adapter. Oh, that's a good sign. I'm still fussing with the connector. All right. Whoa, that's a good sign. Let's see if I can zoom this. Telephoto. Focus. All right. Oh. Yeah, that joystick is very sensitive and it's in the wrong mode again. I think we have a winner here. Hi. Okay, so it's got some areas where the motor is going to go into a buzzy frenzy, which I need to be careful about. There's one of them. Yeah, the joystick is very oversensitive right now. Let me just try moving this around by hand to get an idea of this. Oh, don't be drifting. I cannot drive this yet. Okay. Oh, that's great. I mean, you can see some artifacts from the optical centers being lined up, but it's well within the tolerances of what I was expecting. Oh, and I've still got the power cable attached separately, so it's going to be even better once this isn't dragging, I think. I just saw a brief SDI cutout, but that might have been my connector. Could still be useful as a video amplifier, but Gimbal Town, population us, and some SDI. Alright, well I should definitely wrap up this stream, get on with the rest of my plans for today, but yeah, thanks for joining. I think this was a pretty good success so far. And, you know, a few places where maybe we could wrap up some rough edges on this, but definitely seems to be working. And definitely seems to be on my way to having a good cat camera. As for other issues with this, I'm making some progress on the winches. I decided to just go with a burlier DC brushed motor. So I ordered some that I also should be able to go ahead and put in CAD even before I get them in, since I think I've got decent enough specs. So anyway, thanks for joining. And as always, happy hacking. It seems like Tuco is looking outside and enjoying the birds as the camera struggles to figure out how bright it should be. Yeah, as C4557 in chat says, the smooth pan is satisfying. I agree. Yeah, it seems to have some nice smoothing in the firmware. So, yes, happy hacking, happy quacking, happy Sunday. Enjoy chirping at the birds if that's your thing. And I will see you next time.